Okay, so this problem says an auditorium with 20 rows of seats has a 10 seat in the first row. So first one 10. Right, okay. So second one, each successive row has one more seat. So this second one 11 like that, right? And 12, okay, like that. So here totally we have 20 rows. Okay. So if students take an exam are permitted to sit in any row but not next to another, student, then the maximum number of students that can be seated. So maximum number. So first one we say we have 10 of them. So let's say 10. So could it be seat, then nobody can sit next to her, next to the students, right? Okay. So we have 5. So we say number of students. First one can be 5. So second one 11. So we have odd. Could be like okay. So here we have odd. So odd seat. So last one we can sit. So this one actually we have 6. Like here we have 10, right? Yeah, 10. Then one more. So 10 seat. There's a 10 seat 5. That plus 1. So from here we can say like if even like 12, then just 6 half. Then 13 just plus 1. So this is 7. Okay, so we can find this way. So what is this numbers? So could be like first one 5, then 6, the 7, 8, 9, 10, like that. So here let's say, so totally how many row? Okay, so 11 like that. So let's say we have 20 rows. So last one can be how many? So let's say so last one how many? So here if we have 10, 11, so what is how many students here? Last one. So this is just like a arithmetic sequence. So 10, 11. So we have first number 10. So a what is like we have this sequence 10, 11, 12, 13. We have 20 of those numbers. So last one should be 30. Oh, let's see. So here's A1. So we want to find A20, right? So A20, we say A20 equal A1 plus, so here 19 times D. So D is 1. So this last one should be 29. Okay. So here we can do this way. like we just pick even numbers, 10, 12, then last one is 28. So how many students from them? So half, right? So just this is equal to 5 times plus 6 plus plus 14. So from 10 to 28, from 5 to 14, how many numbers? So that's equal 5 plus 14 divided by multiply n divided by 2. So what is n? So so this minus this plus 1. So this n, yeah, we need to find n. N is 14 minus 5 equal n minus 1 d. D is 1. So this is, we have 10 here, 10 of them, 10. Okay, also we can say, so we have 10 numbers, then 11, 13, 29. Also have no, yeah. So for this we have like 6, so plus 7 plus, so last one should have 15, right? 15, 6, 7, 15. So what is this number? So this equal, and so this equal 6 plus 15 multiply n divided by 2. So this n, I think is also 10, right? 15 minus 6, actually 15 minus 6 plus 1, yeah, equal 10. Okay, so we can find this equal 10. So this the total number of students can be 5 plus 14, 5 plus 14, then multiply 5, then plus 6 plus 15 multiply 5. Okay, so this is equal 20, 30, 30. Sorry, 20, 20, 40. So there's 40 multiply 5. So answer is 200. So at the most that we can have, can sit 200 students. Okay. So for this problem, it says this cat sit here and set. Oh, okay. So here is the cat. Move. Cat move this way. Cat. Okay. Cat move this way like 1, first one, 2, 3, 4. Just move this direction, right? Okay. And the mouse. So cat, the mouse. The mouse move this way. Here, 1. Oh, cat, mouse move this way. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 6, 7, 8. Oh, so mouse moves this way. Yeah, 1, 2, 3, 4. 1, 2, 3, 4, 6, 7, 8. Then 1, 2, 3, 4. Just repeat. Okay. Okay. So we can say like the cat repeat. We say cat period is 4. After 4, the same, right? So the mouse 8. So we want to find at after so many move 247. So we just find 247. We just find remained 247 for cat. More cat 4. So equal 3, right? For mouse, we just say 247 to 8. So this equal 7. Okay, so we can say the position is like that. Okay, so for cat 1, 2, 3. So cat is here, and for mouse, mouse is 1, 2, 3, 4, 5, 6, 7. Mouse is here. Okay. So this problem, actually we can regard this is remain the problem, right? Yeah. Also, okay. So we have, so here we have this kind of sequence we call geometry. Geometric sequence. So 1, 2, 4, 8, 16. So just a double. So in general, those geometry sequence is first. So if first number is A1, then second one number is A1 multiplied some number. A1 multiplied some number, or just A1 just A multiplied some number. So the same number, the multiply R, right? Okay. So we have this for geometry sequence. A, we can say AN just equal A multiply RN minus 1, and A1 just equal this A, okay, A times RN minus 1. So from AN, from AM to AN, we just multiply R, multiply RN so many times. Multiply RN minus M. Okay. So for geometry sequence, we also need to add them up. Like first one, so first one is A plus, we want to find this summation, like A first one plus second one plus 31. Okay, plus AN, so AN ARN minus 1. So for this problem, we just take A outside. So just equal 1 plus R plus R2 plus R3 plus RN minus 1. So for this summation 1 plus R plus R2 plus R3 plus RN, we have this formula. Okay, so this is important formula. Okay, so maybe we should remember like 1 plus R squared plus R n's power. So equal, here just increase by 1 minus R n plus 1 over 1 minus R. So how can we get this? So the so So here actually we just try to remember this and use this. So if we wanted to understand more, if we wanted to understand how can we get this, so here we also can explain this. So suppose this is S. Then how about S multiply R? R multiplied by S equals this, right? So we say this one minus this equal R plus R2 plus Rn plus 1. So here's 1 plus R squared plus Rn. So this minus this cancelled, this cancelled, and this cancelled. So this become like Rn plus 1 minus 1, right? Okay, so we can take it here, take S outside. So S R minus 1 equal Rn plus 1 minus 1. So we have this formula, right? Rn plus 1 minus 1, or R minus 1. Okay, so sometimes we can write this. So so sometimes we use this. So those two just these two just same. So it depends if R is less than 1, we maybe use this. If R larger than 1, use this. Okay, so use this, we can find those summation sum of this. So for this problem, we just take 2, 5 outside. So this become 1 plus 2, and then plus 2. So here 1, 2, 0, 2, 1, then 2, 15, right? Okay. So we can use this formula. So this here R is 2. 1 plus R squared plus R 15th power. So this equal this 16 minus 1, 2 minus 1. Okay. 2 minus 1 equal 2. So this equal 2, 5 multiply 2, 16 and minus 1. Okay, so those arithmetic sequence, we can regard this just like a forced polynomial equation, forced polynomial function. Like let's say, for this arithmetic sequence, we have this like an. So if we regard n as x, so just d times x plus constant. So this we can say this arithmetic sequence is a fourth degree polynomial sequence. So we also can have the second like this. An equals some number an squared plus bn plus c, right? So we can have second degree. Okay. So we say sometimes this things related to n squared. So just like that, a big square is formed by some small unit square, just like that. Like suppose this is a small square. So put a small square. So for square we can make this square. So okay. We can make a big square, right? So this length 1, so here length 2, okay, so length 3. So if this side is n, so how many how many small square? So we know this should be n square, right? So we have this. We say suppose this is let the number of square is n. So n equal 1 is 1, n equal 2, n equal 3 is 9, n equal n, so n square, right? So we have this relationship. N is equal n square. So we can have those kind of problem. Like, let's say a sequence of square is made of identical square tiles. The edge of each square is one tile length longer than the previous one. So here this is 1, then this is 2, just like that, right? 2, then 3. Okay, so let's see the question: how many more tiles does the 7th square required than the 6th? So we want to find A7 minus A6. So what is AN? So actually AN is n square, right? So this is just equal 7 square minus 6 square. Okay. So we also can consider like how many, let's say how many edges, or if we make those picture by toothpicks, how many we should use. So here we should use 4, here we should use, let's say how many? We maybe need just 12, right? So so such a problem like how many pigs, how many edges, so those kind of problem is just second degree sequence. AN is related to n square. Okay. So maybe let's check this problem. Like, okay, we have, let's say just like that, like we use toothpicks to make a grid that has 60 toothpick long and 32 toothpick wide. So how many toothpick are used together? So for such a problem, we just check some. So here 30, so those 60 or 32, those numbers big. So let's check a small number. So let's say how about this, like here, longer is 3, and okay. So here we put this longer as, let's say M, here as N. So here if M equals 3, N equal 2, so totally we say put a T, it's a T equal what? So we can say this equal like 3, 3, 3, 3, 3, 3, so 3, so here's 3 multiply 3. So this 3 is, we can say this is just equal 2 plus 1. this is 2, right? So B, if we have 2, then we say we have 3 rows, and then plus. So in this case, like okay, so we say we need so many for this horizontal. So vertical, how many vertical? So we say this is 4, this is 4, this let's say this is 4 multiply 4 times 4 multiply 2, right? Yeah. Okay. So we can change. We can write this in terms of MA. So this is equal M n plus 1. M is number rows of M. We have 3 rows, 3, but n plus 1. Yeah. If we have 2 n equal 32 wide, n equal so plus. So if so, we just check horizontal. We need so many. Vertical, we need so many. So vertical, we need 4. So this 4 is m plus 1. Right? 3 plus 1. n plus 1 multiply n. Okay, so we can check like for small m, so we can have this formula. So for big N, so we can regard this is so for big N. We also the formula also true, so we can use this. So T so equal M. M is 60 multiply N is 32, right? 32 plus 1. So then plus M 60 plus 1 multiply 32. Okay. Let's see. Okay, so such a problem. This problem is a good problem. Like so the idea is we just check some typical case, easy case. Some easy cases, then we try find a way. Okay, find a formula. Right. Okay. So here we have a modified geometry sequence. So geometry sequence is an equal like suppose like 2 times an minus 1. So just multiply 2, multiply 2, multiply 2. So this is a geometry sequence, right? So now suppose we change a little bit. Suppose plus 1. So we need to find. Sometimes we need to find the formula. For this problem is easy. We just find a few of them. Find A5. So A0 equal 1. So just 1. So second one is multiply by 2. So become 2. So plus 1, 3, right? Then multiply by 2 plus 1 becomes 7. Multiply by 2, 14 plus 1, 15. So multiply by 2, 30 plus 1, 31. Right? So this is here's A0. Okay, so A1, A2, A3. So we need one more. Multiply by 2, 62 plus 1, 63. Right? So this is A5. Okay, so here we try find a general formula. We want to find A20 or A20, so we cannot use this way, right? We should find a formula. Okay, so from here, how can we find a formula? So the idea is we just change a little bit. We just consider an plus x. Okay. So we just change this to an minus 1 plus 1. So we just plus x on both sides. So an plus x equal 2an minus 1 plus 1 plus x. So our idea is we want to regard this is as Bn. So this is Bn. So we just put this. So we changing here, so we regard this is 1. So this should be an minus 1 plus x, right? Plus x. So here become 1 minus x, right? So if this 1 minus x equals 0, so we just let 1 minus x equals 0. Okay, so we can get the Bn equal to Bn minus 1, right? Or if this equals 0, so we can have, so we get this. Maybe we can change this as Bn, or we can keep original 1. So we have this. So okay, so we regard an plus 1 as 1 term. So okay, so from here we can say, oh, this equal 2 times this, and then 2 square multiply 2, like 2 square an minus 2 plus 1, and so we also can say a3. So we can so an minus 3 plus 1. Yeah. Okay. Then we find the padding. We say, so we let's say, so here n minus 3, then here 2 3. So here n minus n is 2n, right? So we find an plus 1 equal 2n. Then here is n minus n 0 plus 1. Okay. So what is a0 or a0 equal 1? So we can find the general form. Okay. Okay. So this equal, we also can say like 2n multiply 2, right? So we also can put this 2n plus 1. So an finally we say equal to n plus 1 minus 1. So we can get a formula for an. Okay. So sometimes, oh, okay. So for those problems, oh, okay. Maybe we should stop here. Yeah. Okay. So let's stop here. So this is also typical example, right?